Okay, we get ready to hit, yep, we get ready to hit this right now. Okay, it's 11:30. Let's get it popping, y'all. Welcome to the live. This is Professor TK the Chemist. So for those of you all that are coming in here for General Chemistry 2, you are in for a treat. I take my time teaching the material that I know a lot of students struggle with. And I know that in class, it's often faster paced, but guess what? It's okay because this is where I come in to help you. So what I'm going to do today is I'm going to actually go over Arrhenius practice problems. Now, y'all probably wonder, why do I need to know this? Like, how is this going to help me in chemistry or in the real world? I actually got a video I'm going to talk about this on. But check this out. If you have ever taken medication before, which we all have taken Benadryl, an antibiotic, the purpose in using Arrhenius questions or Arrhenius problems is to make sure that you know when that drug is going to expire. That's the whole purpose in that. If you take medications, we use Arrhenius theories to figure or calculations to determine when is this drug going to no longer be effective. How long is it going to be good on the shelf? If you are wearing makeup, wearing lipstick, eyeshadow, again, Arrhenius calculations are key to that because it lets you know how slow or how fast it's going to go in terms of being expired. So when you all look at these problems, okay, there is the main formula that you would need to know for Arrhenius calculations. And I'm going to actually give them to you so you will know what to use and how to use it, okay? Formula that many of you guys are used to seeing looks something like this. Matter of fact, let me go ahead and put it up on the screen so that you all will know what I'm talking about, okay? And I'm going to actually show you how to use this problem. You may have seen something like the natural log of K. And let me scoot it out a little bit so y'all can see it, okay? The natural log of K equals the natural log of A minus the activation energy over your R and your T. Now, I color code a lot, okay? I color code a lot, and because I color code, that means I actually use colors to identify what you're working with, okay? So in this problem right here, for the very first problem, let me zoom in so y'all can see that. Problem number 1, we're going to actually solve for the rate constant, okay? Notice here that I'm giving you the R. The R is your constant that you have to have in order to solve the problem and your units. Make sure that if your temperature is in degrees Celsius, you convert that to Kelvin by adding 273 to that number, okay? Make sure that if your energy is not in joules, you put it in joules. Sometimes we may put it in kilojoules, but you've got to convert it to a joule. So I'm going to go ahead and set this problem up. I'm just going to go ahead and give you all the K, okay? Since they're asking us to find the K, here is the formula that you are going to use right here, okay? And you do need a calculator. I will use one online so you all can see it, okay? And this is your formula right here that you all are going to use. Now, first up, if you noticed here, you've got the frequency factor, which is this number right here, okay? So that is this right here. The other, and I'm color coding so you all can see. The activation energy is this number right here, okay? That negative 45 kilojoules per mole. Also, your R that they gave you in the problem right here, that's this number on the very bottom. And then your temperature right here that they gave you is this number right there, okay? Take a moment to look at what I just did so that you know how to plug in the values. Now, this, by the way, is dividing. you're dividing. So whatever you get here, okay, you're dividing these two numbers to get raised to the e of your number here. Now, what I'm going to do in slow motion, I'm going to plug these numbers in. I've got, and remember, okay, remember, if you take your time in doing the problems, everything will make more sense to you than if you're rushing through it, okay? So you want to take your time. 2.0 times 10 to the 12th per seconds. That's what that s to the negative 1 means. It means per, okay? Times e to the negative, your activation energy is 45. Now, let me say something about this, though. You see where that 45, before I put it up there, that 45.0 kilojoules, you must convert that to a joule. You got to convert that to a joule because otherwise your answer is going to come out wrong, okay? So to convert that to a joule, I am going to multiply that number times 1,000. So I'll end up with 45,000 joules per mole, okay? Divided by your R is 8.314 joules per mole. Right there. And it's hard trying to put everything there, okay? Per Kelvin, just like that, okay? And then, what's the other part that you've got? The temperature, okay? The temperature, which is 300. So again, I'm gonna write this out and I'm gonna break it down again so that you all can see everything that we're doing right here, okay? Because this is a lot. This is a lot, and I don't want to lose you because sometimes when students see this, they get aggravated. Let me make sure that you all know that this E right here, okay, this E is to the negative all of this that you see right here, okay? That's what that E is right there, okay? So let me make sure that you all are aware of that. This E is raised to the negative, all of that right there, okay? All of that. What we're going to do, we're going to first divide these. Okay, we're going to multiply these two numbers right here first, okay? Multiply those two numbers first, and then you're going to divide. That way, you will have your E to the negative, whatever that's going to be. All right? Before I continue, I'm going to let you all just look at that for a moment, okay? Before I continue. All right, now, what you're going to do, let me zoom back in so you all can see this, okay? Remember, do this part of the math first, okay? Do that part of the math first so that you're able to establish that portion of your answer. So I'm going, and look, and by the way, I'm going to go ahead and cancel out the units. I don't need the joules anymore. I don't need the moles anymore. I don't need my kelvins anymore. Okay? Your K is going to have per seconds as the unit. Okay? Your K rate constant unit will be per seconds. So that's why all those other units canceled out, okay? So right here, let me go ahead and I'm going to finish writing everything out. K is equal to, again, 2.0 times 10 to the 12th per seconds times e to the negative. I'm going to go ahead and do the math for this part right here, okay? So let's go ahead and plug this into our calculator. I'm going to go ahead and determine I've got 45,000 on the very top divided by, let's go ahead and plug in 8.314 times 300. Hold on, let me turn on my extra light. Hold on, y'all. Okay. 2494.2. Okay. Now, I am going to divide those two numbers right there. Okay. 45,000 divided by 2494.2. That's equal to 18.04. Okay, so K is equal to, and again, you all may think that this is redundant, writing it out all the time, but guess what? You've got to incorporate those numbers because this allows you to go back in to see your mistakes. Okay, y'all see this right here? Now, go ahead and plug this into your calculator, okay? So that way you will know what the answer should be. All right, so I'm going to go ahead and plug this into my calculator. 18.04. See this right here? And I'm going to go ahead and put in, this is the way mine works. I got to hit the shift and the natural log button. Hold on. Make sure y'all see that. Okay. 18.04. Okay. And I get 2.89. Okay. 2.89. But if you don't put the negative in there, you're going to get a different number, okay? So let me show this to you all again. I'm going to show y'all. I like showing the mistakes that students make because this is going to allow you all to see why you've got the problem wrong, okay? So let me show it to you again. How if you put the negative sign versus not, okay? Here it is again. Let me show you. Right here. If I put in 18.04, without the negative sign, you see that without the negative sign, and I just put in shift and then the E, I get a completely different number, okay? So you got to make sure that you raise that up. So don't forget to put in the right answer, okay? Don't forget to put in those signs because those signs makes a difference. Okay? Those signs make a difference. So 18.04, okay, with a negative sign, and then in my calculator, shift, and then that little E button, I get 1.46 times 10 to the negative 8. Okay? That's what this E right here is equal to. So my K equals 2.0 times 10 to the 12th per seconds times 1.46 times 10 to the negative 8th. Well, I'm going to multiply that times 2.0 times 10 to the 12th, and this is what I get, 29,265. But your professors may want your answers in scientific notation. So I'm going to go ahead and put this in scientific notation. So it's going to end up being 2.93 times 10 to the 4th per seconds. Okay? I'm going to reevaluate this problem one more time so that you all can see what I just did, okay? Because I know this was a lot. This was the question. They wanted you to determine the rate constant of K, okay? These were the values right here that was given, okay? This was your problem. The activation energy was provided, the frequency factor, and the temperature. This is the formula that we used. I color-coded it so that you all would know what numbers go where. So the color coding works so that you're able to know what numbers go where. Then I plugged in, and it's kind of hard to see, but right here, I also made sure that my activation energy was in joules. And the way I made sure of that, I multiplied 45 0.0 times 1,000 to get it in joules. Why? Because you're going to cancel that out with the gas constant. The gas constant is in joules per moles Kelvin. And because of that, you want to make sure that you have the proper unit. If you kept this as kilojoules, all of this would be wrong. So you want to make sure that you have the right numbers. So that E to the negative activation energy divided by the gas constant and the temperature, all of this equals negative 18.04. Make sure, let me zoom in so you all can see this. Make sure that you put in the correct E value. If you leave off that negative sign, you're going to get a completely different answer. So make sure that you put the negative sign there. And then when you do that, you end up with 1.46 times 10 to the negative 8 times your A, your frequency. And so your K rate constant is equal to 2.9, technically 2.9 because you only need two significant digits. So let me erase that 3 because you don't need the 3. So it's technically 2.9 times 10 to the 4th per seconds. Now, I know that was a lot, but guys, chemistry requires a lot of steps, okay? It requires a lot of steps. So we're going to do another one, okay? We're going to do another one. And this one, excuse me, right here, deals with solving for activation energy. Now you're going to have to use the formula for E of A.